Any questions from last time? Last time was lesson 3.3, conditional and the biconditional. So we did these two guys last time. Okay. See if somebody's walking by the door. Secret. We have a secret society in here. Any questions from the assignment? You got one back there? Good. Find it? 41. Okay, 41. I think I got it up there on the top. Let's make sure I'm in the right place here. Question was, from problem 40, it's clear that the negation of if P then Q is equivalent to Pn negative Q. Verify this by means of a truth table. So verify that the negation of if P then Q is equivalent to Pn not Q. So in other words, this part right here, show this. Show that this side is equal to that side. This is just my prelim stuff, my P and my Q, and I threw in a not Q because we had one over here. So standard setup, not Q, just the opposite of Q. Now here comes the big one, if P then Q. I'm not doing this yet. I'm gonna take that at the end. So if P then Q. Only time it's false is when the first one's true and the second one's false. It's kind of interesting that I left that one off the quiz, wasn't it? Weird. Anyway, I should have really had that on there. So that's the only one that's false. Now I have to negate this. So here's my answer to the left side, FTFF. Right side, Pn not Q. So I got to take these two columns and use this rule, which is only true when both are true. False, true, false, false. Sure enough, those two columns with the regular arrows are identical. So we've done it. We've illustrated that they really are equivalent. Somebody else, was it someone else? You were going to ask one, yeah.
Yeah, 7 and, or I mean 9 and 11.
Okay, 9. Yeah, if 2 plus 2 equals 22, then x minus 2 equals 5. And it says find all the numbers that will make it true. Okay? Now here's the tricky part to this. That first part, the if part, is very obviously false, isn't it? Okay, now, what do you know about an if-then statement where the first statement is false? No, but, and that's kind of a tricky question. But look up here on this if-then table. Do I still have it up here? Yeah. On this if-then table, these were the two statements that began with a false. What did you notice? So, remember we talked about this. It's ironic, but when an if part is in an if-then statement, if the first part's false, you're guaranteed to have a true. Okay, now keep that in mind in answer number 9. So if the first part is false, which it is, the second part's guaranteed to be true. So do we care if the second statement is true or false? It sounds terrible, but we actually don't care, do we? Because it's guaranteed to be true. Therefore, what does x have to be? Couldn't it be anything your little heart desires? That's the idea behind number 9. What is, let's see what 11 is. If x plus 2 equals 6, then 2 plus 2 equals 32, and you were supposed to make it true. Okay? Well, 2 plus 2 obviously does not equal 32. correct? Now, think about it. If the second statement is false, okay, look up here. Again, sorry, this column is separated from these two. But if the second statement is false, it all depends on the first statement, right? What we don't want is for the first statement to be true, because so you gotta this is ironic, but you gotta actually pick an X that'll make that first part false. And what will make the first part false? Anything except 4. So you see what you weren't doing arithmetic so much as we were trying to get you into this convoluted reasoning behind these. These are really unusual in that regard. Like twice we were desiring to get something false here so that it would be true. And that's a little bit weird to get used to. Glad you asked about that one. Yes? 53. Okay. Let's see if I got that one in here. I don't know. No, I guess not. Okay, 53. The problem states, a mother promises her child, if you eat the spinach and the liver, then you may go out to play. The child eats only the spinach, but the mother lets him go out and play. Has she broken her promise? Okay, so here's the deal. On an if-then, if the if part is true, then she has to fulfill her promise. What would you say about the if part of this one? Has the kid followed through on the if part? No. So, does mom have to follow through on any promise? Not really. So, the question is, has mom lied or has she broken her promise? No. So, it's kind of like you're out of an obligation if the if part isn't there. So, if I say to you, if pigs fly, I'll give you $1 million at the end of class today. I'm safe because pigs don't fly. So I'm out of my stupid promise. Follow? And so because there was a dual part there, 2 things had to be true for the kid to get, I forgot, what was the prize? Go outside and play. Because the kid didn't follow through on the if part, she had no promise. Now, you know what everybody's thinking. You're thinking that she said, if you do these 2 things, you go out and play. And if you don't, you are the naughtiest boy on the face of the earth, or whatever. And of course, she never said anything about if you don't. But of course, it's implied there, right? Or another one is, there's a guy, this is old-fashioned, but a guy was standing there with a big belt in his hand and says, hey, if you eat your spinach, I'll let you go out and play. Kind of implied, if you don't, I've got something else in mind. But, you know, he doesn't say it, so, yeah. And, you know, it's very common that people right away interpret this, oh, if I don't go out and play and do those things, I can't go, I can't go out and play. And no, it's not stated that way. It's kind of like, here's an example. You guys have all heard this one. Here's a dual promise too. If you believe and are baptized, then you will be saved. Well, that's a Bible passage, slightly modified, but I mean, that's basically it. So what about the thief on the cross? Well, he came to faith right while he was hanging up on the cross. So he wasn't baptized. And yet Jesus told him, today you will be with me in paradise. So did Jesus lie? Now, that's an easy one because we know Jesus doesn't lie. But you see what happened there? Did he say that if you don't believe or you're not baptized, that I won't let you go to heaven? No, he just says, if you do believe and are baptized, you're going. So That's kind of a good example. Okay. Anybody else? Nice review questions. How did we do on the quiz? Pretty good? You guys, I could tell when you came in, a bunch of you had your notebooks open, you were studying. I guess I've been laying a few hints. Good. Way to take the hints. I need to do more quizzing, so just always keep yourself up on that. Well, before we start the new lesson, I wanted to show you something. I thought this is in your books, and I really thought this was excellent. See if you can catch the subtle reasoning here. This is, by the way, this actually happened in a court of law. Okay? I mean, it shouldn't shock you, first of all, the caption. In the field of law, the field of law requires you to apply logic to reasoning and argument. Obviously, that's what's a lawyer trying to do? A lawyer is trying to convince the jury to logically come to a certain conclusion. And of course, the other lawyer is trying to logically convince the jurors the other way. Okay, here we are. A man was being tried for participation in a robbery. Okay, picture, we're in the middle of a trial, and a guy's on trial for being a part of the robbery. And here's part of the proceedings. The prosecutor, the guy that's trying to nail this guy and get him into jail, says, if the defendant is guilty, then he had an accomplice. The defense attorney pipes up, that's not true, Your Honor. Immediately the judge called a mistrial. What? Think about it. Here's what's going on. If the defendant is guilty, then he had an accomplice. That's an if-then statement, right? The defense lawyer says it's false. What's the only way that an if-then statement can be false? Now, you know this. What's the only way this can turn out to be false? True, false, right? So what was he subtly admitting to? What's the first part? If the defendant is... He just admitted his client was guilty. Okay, you can't do that if you're the defense lawyer. That is, the judge is correct. That's a mistrial. Do you follow that? Most people don't get that. But if this statement is really false, then he's admitting that this part's true. Whoops. Mistrial, waste of money, probably a black mark on his lawyer record. You know, I mean, they go through a fair amount of money to get all the jurors there, all of this junk, and then to have it get goofed up like that. They're not really too thrilled about that. Yeah.
Number 60 in the exercises for today, I had something that's very similar to that.
Did it?
From the insurance policy.
Cool. Yeah. Thanks. I'll have to look at that one also. Okay. Now, here we go. This is lesson 3.4. It's called Variations of the Condition. And I got a graphic there, but that's just like an intro, so. Well, I have good news for you. Today, I'm not going to give you new rules. But what I am going to do is we're going to take this guy, one of the statements we had last time, and we're going to turn it around in all kinds of different ways. We're going to kind of twist it and turn it. In fact, we're going to do it 3 different ways. So we'll just take our generic if P, then Q statement. By the way, I don't know, I never made a comment on this, but have you noticed how logic uses a lot of P's and Q's? I'm not quite sure why that is. I think P stands for premise, but I don't get the Q. But anyway, that's kind of where the old mind your P's and Q's comes from. It's kind of unique. So anyway, here's our generic statement, if P then Q. If we just swap the 2 letters, we have a special name for that. That's called a converse. If P then Q, and if we just changed it into if Q, by the way, you can't just do that. But that kind of a change is called a converse. Notice in this next one, I left the P and the Q in the same order, but what did I put in front of the P and the Q? A negation, a not. So if we change if P then Q to if not P then not Q, that's called the inverse. And if we do both, if we turn them around and put negations on both of them, that's called a contrapositive. Okay, it turns out the bottom one is the most important one. They're all kind of important, but the bottom one is the most important because it turns out the contrapositive is equivalent to the original. And sometimes using the contrapositive of a statement makes it clearer. And it has exactly the same truth value. I suppose I should first prove to you that that works. So here we go. So if you notice over here on the left, here's the original, if P then Q. And on the right side, I've turned them around and knotted them both, right? So QP, if not Q, then not P. Contrapositive. So here we go. What's the truth table for this one? You know, only false when first one's true and the second one's false, right? Okay, now to help us with the second part, I stuck a couple of knots over here. Let's just make sure. Did I do it right? Is this not Q column the opposite of that Q column over there? TFTF, FTFT. Okay. And this column should be the opposite of the P column, TTFF, FFTT. Now, here we go. Can you if then these two columns? Okay, if false, then false. It's always true when the first one's false, right? If true, then false. That's the bad boy, right? If false, then true. That's true. Starts with a false. If true, then true. That's true. So there it is. Now you can't quite see my arrows, but do you see that these two columns completely 100% agree? Therefore, a contrapositive is exactly equivalent to the original. Let's see. Let's see if I can make one up. Do you remember the other day I used this example? Kind of corny, but I said to my wife, if I get out of work by 5 o'clock, then I will go buy bread. Remember that one? Okay, what's the contrapositive of that? If I don't go buy bread, then I didn't get out of work by 5 o'clock. And do you see how that means the same thing? Now, sometimes when you reverse them like that, they are clear. Or how about the one here? Simplified version of today. If you eat your spinach, then you may go out and play. What's the contrapositive? If you can't go out and play, you must not have eaten your spinach. See how I negated them both and I turned them around. Please note, the other two guys are not equivalent to the original. Let me show you, let me try to take the, should we use the bread analogy? Okay, if I get out of work by 5 o'clock, then I will buy bread. The converse is, if I buy bread, then I got out of work by 5 o'clock. That's not the same thing. Be careful. Or how about the inverse? If I don't get out of work by 5 o'clock, then I will not go buy bread. It's not the same as the original either. But that last one, if I didn't buy bread, then I didn't get out of work by 5. That one is one. And by the way, I can prove it to you again. All I got to do is show you. Let's run through the truth tables of these, and you'll find these are not the same. By the way, these two are the same. These are equivalent to each other, which is nice, but they don't agree with the original. So these two guys agree. They're the important ones because this is the one we started with. So this guy is good. These are not equivalent, but they're equivalent to each other. So in other words, they're both equally bad. if that makes any sense. I've got a little graphic here that kind of illustrates this. Well, this shows that the original statement and by the way, this is on my Math for Life website. I don't know, again, if any of you have gone there, but you see how the first and the last columns come out the same, TF, TT? And look at the truth value in the two inner columns. Look at what the converse and the inverse come out to, TTFT. They're both the same as each other, but they're also not the same as the original. So it's important to note they're equivalent to each other, but still they're not correct. Now, we got some language considerations I need you to think about. There's some words that we're going to use that you need to latch onto. One of them is the little phrase, only if. You're going to see a few problems that have this in it. So for example, P, only if Q. Or, like, I get out of work before 5 o'clock only if I buy the bread. I'm just, whatever the P and Q are. Now, here's what only if is translated as. In effect, it says, it says if not Q, then not P. Does that look familiar? Isn't that the contrapositive of if P, then Q? So when you see P only if Q, you can just translate it as if P, then Q. So only if is a friendly guy because the P and the Q stay in the same order, and it's just like a normal if then. And again, I could prove this to you. Well, I'm not going to prove the English part to you, but we've already seen that these two are equivalent. Now, so lesson number 1 for language. The words only if, when placed between two statements, is the same as just putting one of these in between the two statements. Okay. Lesson 2. The word sufficient. Now, I know you've all heard of that. We say that if P then Q, P is sufficient for Q. So it's kind of like, I'm trying to, getting out of work by 5 o'clock is sufficient for me to buy bread. It's kind of what it's saying. Okay, but now, here's that one's easy. The first guy is sufficient for the second. But now this is the one that gives people trouble. Necessary. We say that Q is necessary for P. Notice that's reversed. Q is necessary for P. Here's what that means. It's necessary for me to buy bread if I get out of work by 5 o'clock. That is, if I want to get in the house and not sleep in the doghouse tonight. Okay? It's necessary because I made a promise. It's necessary for me to follow through, so to speak. So here's the way I remember it. Sufficient, same order. If P then Q, P is sufficient for Q. Necessary, opposite order. If P then Q, Q is necessary for P. Whatever memory aid you can come up with, please note that reversal on that last one. So there's 3 things for you to file away and study. And then, here's another one. The word implies. Implies. What's the noun form of the verb implies? Implication. And we're going to talk about the noun form too. She's right. So we could call, we could say if P then Q is an implication. Only when if P then Q comes out to a tautology. Now, I think I've already taught you that, haven't I? Have I taught you what a tautology is? Okay, it's really easy. My apologies. A tautology is a truth table where every single entry is true. A tautology is a truth table where you got all truths all the way down. Have we had any like that yet? I think we may have, but not very many. Usually there's been at least one false, but I think we've done it. Anyway, there are some that will come out all true. So, if you do your if-then analogy and it comes out to all truths, then we say that P implies Q. And it's so important that we even have a special symbol for it. This is the symbol for implies. It's like an equal sign with an arrowhead on the right of it. Just a little different. This is if-then. This is P implies Q. Okay? So I know we're giving you a lot. Actually, symbolism is a big part of this chapter. Because now, think of what I've given you. I've given you this. Then I gave you this with an equal sign in between. Remember the difference? This is the biconditional, if and only if. Then when you put an equal sign in here and arrowheads on both ends, that means is equivalent to. And then when you do this, that's if-then. And then when you do this, that's called implies. There's like 4 symbols, and they all look very much alike. I've got them kind of all down here. Here's the if-then. Here's the if and only if, or the biconditional. Here's the equivalent. Here's the implies. So this statement over here, using symbols, says P implies Q. I like to think of it this way. Take an if-then, if P, then Q. And if it turns out to a tautology, it's like getting promoted to a sergeant. You get an extra stripe. You're even more important. Okay? You've just been promoted. So this is better than this. Because this is an if-then that really comes out special. Comes out all T's. Okay, I know that was kind of a lot to stomach, but we're going to see if we can practice here. Yeah, here's one that comes out to a tautology. Okay, so it says, show that this ugly thing right here, if P then Q and P, show that that implies Q. Okay, well, the way to do it is to check out if this, then that, and see if it turns out to a tautology. So you notice, if this, then Q is my setup of my truth table. Yeah, okay, this is going to take a little while. So we do our standard. Good news, we only have 4 letters, so, I'm sorry, 2 letters, so we only need 4 lines. If P then Q, you know by now it's only false when true on this side and false over there. So there's my only F. Okay, now I got to and that with P. So I have to take this column and this column and AND them. And the rule for and is true only when they both true. True, true? Yeah, that's true. True, false? No, that's not. False, true? No. False, true? Nope. So far, here's where I am. Part 1. Okay? Part 2. I got to if then that with Q. So I got to take this funny looking circle guy and do this with this circle guy. So if this, then this. Remember, how does this work? Only false when true, false. So, true, true. False, false. False, true. False, false. Cool. True all the way down. Da, 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 da. A tautology. He gets a promotion. This was an if-then statement that turned out to a tautology. We promoted the sergeant. We say, this ugly guy implies this guy. And you write that like this. You don't have to put the double exclamation point, but it's kind of rare. That's why I got all hyped up.
I'm just curious, what's the three sort of dots in the triangle in front of him?
Yeah, that is a logic way of saying therefore. Yeah, everybody, you've probably seen me do that before. Therefore, it's another math teacher's shortcut. Actually, logicians, people who do logic, use it all the time. Instead of having to write the word out, or hence. Yeah, thanks for asking about that. So you think you got the idea on what an implication is. So that's an implication. That's the noun form of the word implies, right? Those are pretty cool implications. And they're kind of rare. Okay, let's take a look at number 50 in the book. This is another question about implications. Number 50 says, there are two statements given here. Tell whether they're equivalent, whether one implies the other, or neither. So, two things. Actually, three things to look for. Are the two equivalent? If not, then check if the first one implies the second one, and if not, then check if the second one implies the first one. And if none of those work, then you're just supposed to write down neither. Okay, well, guess what? I already got my conclusion down, but anyway, here are the two statements they gave us for number 50. One is if not P, then not Q. And the other one they gave us was if not P, then regular Q. So I first figured out the truth tables. Let's do that. Standard setup, I've got a not P and a not Q to help us out here. If not P, then not Q. So if false, then false. That's true. That's true. That's the bad one, right? False, true. So true, true, false, true. Okay, then I went through and did this one. If not P, then Q. Can you do it backwards? If this, then this. If false, then true, that's true. False, then false, that's true. True, then true, that's true. True, then false, that's false. Okay, so that's nice, but we're not done. Now, here's the question. Question one, are these equivalent? You can see right away that they're not, right? Okay, that was an easy one. Now, could it be that this one implies that one? Well, the only way to find out is to do an if-then. So, let me start doing that. I'm going to get this out of there. And let's change this all so it's blue. Okay. So, here's what we're going to do. We are going to do if the first, then the second. You know how this works. Only false when the first one's true and the second one. So, if true, then true. If true, then true. If false, then true. It's looking good. Okay, why I say it's looking good? Because we had a tautology going, but it did fail. So does the first quantity imply the second? No, no tautology. So that's out. So we only have one thing left to try. I don't normally like to do this, but so I don't have to write it all over again. Now we're trying to do the implication in the backwards order. Okay, so can you think in reverse here? If true, then true. If true, then true. If true, then false. Did we get a tautology? No. So, the final question in the book was, are they equivalent? We said no right away. Does the first imply the second? Nope. Does the second imply the first? Nope. None of the above work on this one. And that's one of the possibilities for the directions. It says, determine if they're equivalent, one implies the other, or neither is the case. Neither is the case. So you would just write down. Okay? Does that make sense? So that's the kind of unique set of directions above number 50, 48 there. Okay. We should check an assignment. Let you guys get going. By the way, here's number 52, the same section. This time, I found out they were equivalent. You see how they're both TTFF? And by the way, if they're equivalent, don't bother checking if they imply each other. I got to think about that. If they're equivalent, they do apply, but you don't have to check it. You can just say they're equivalent. Okay, maybe we should look at this. Here's all our, look at, these symbols are starting to add up now. Do you know what all of these mean? Looks like maybe I'm an Indian who's carved things on rocks outside of some very remote town in Arizona or something. But anyway, here they are. And the inclusive or, the negation, we got the exclusive or, it's called the conditional, it's the if-then statement. Then we got the biconditional, if and only if. Then we got equivalent, the equal sign in between. And then this new one from today. That implies that. I don't know, a lot of symbols, so don't just study your rules, study your symbols. And that's why I've been doing these crazy hand signals, because I've been trying to get you used to the symbols. I don't think I have the assignment up here, so we'll look it up. Here it is. I don't know why I have part of it red and part of it not, but 1 to 53 the odds. And on Friday we're heading for Euler diagrams. Thank you. See you on Friday.